Welcome to this video, which is an introduction on vectors. What we're going to look at for this video is adding and subtracting vectors, multiplying vectors by a scalar, and parallel vectors. First of all, let's have a look. Vectors look like this. If you want them to, we can call that vector A. They can look like this from one place to another, O to A, or even A to B. They can be drawn with the arrow in the middle. They can have a little squiggle under them, or they can just have a bold letter A. So there's heaps of different ways we can represent vectors. Generally, we'll be looking at this way or this way, but there might be quite a few, especially these directionals, when we start having a look at vectors between 2 points. Now, adding vectors is quite straightforward. So if I have a vector, let's imagine it looks like this, we'll call it vector A. And I have another vector, let's say it looks like this, vector B. When I add them, all I need to do is put them top to tail, which is quite easy when I'm doing this. And I'll move this one across to here. And the resultant vector, A plus B, goes from here to here. So that's meant to be a straight line, but that's the resultant vector of A plus B. You can do that top to tail anytime you're adding two vectors. To subtract two vectors, or one vector from another, let's imagine again we have A and B. So here is our vector A, and here is our vector B. What we do, if I want vector A minus vector B, what I'm going to do to this vector here is I'm going to write it the exact opposite way. So this is now negative B, and I'll therefore add negative B to positive A, so that's going to be A plus the negative B, which is going to graphically or geometrically look like this. And there's the negative B. So that's the resulting vector of A minus B. Now, so far we haven't actually quantified any of the vectors. So let's imagine we have a vector A, which is 3i plus 2j. What that means is that the i's move in the x direction. So let's imagine that it'll look something like this, 3 going across and 2 going up. So therefore the vector A you would expect to look something like that. And remember, vectors aren't all about a placement, they're about a displacement. So the amount that something moves, which means the vector A here, which might go from the origin to some point A, that's exactly the same as the vector if I draw another identical vector but in a different location that goes from point B to point C. If this is the same vector, then my coordinates of point C, imagine here's xy, this will be x plus 3 and y plus 2 according to this rule here. So it's about the displacement, the distance from one point to another that a vector is talking about. Now, if I'm going to add this vector A to another vector, let's imagine vector B is I minus 3j, then I can simply add the i's and add the j's. So I can do it graphically like I did on the last page, or I could say, therefore, A plus B equals 3i plus 1i is 4i, and 2j minus 3j is negative 1j, and my resulting vector of A plus B would be 4i minus j. In the same way, if I were to subtract vector B, it would be 3 minus 1i, so that gives me 2i, and 2 minus negative 3, which would give me positive 5j. So I can add vectors like that. Furthermore, I could even write this vector in terms of a matrix where I write 3, 2, or so on. And finally, vectors can also be in 3 dimensions. In 3 dimensions, my vector would be written something like 2i plus 3j minus 4k. And they're the 3 different dimensions, the x, the y, and the z dimension. And vectors, we normally write them ij and k. All the properties that we've already talked about with adding and subtracting still hold whether a vector is in 2 or 3 dimensions. Now, scalars. A scalar is a number that we might multiply a vector by to make it bigger or smaller. Remember, vectors all have direction and magnitude. So they have a length, which is how long the arrow is, and they have a direction. So something like velocity, acceleration, displacement, and so on are all vectors. Scalar is just a single number. A scalar is a number, but with no direction. So something like speed is a scalar because it doesn't talk about which direction you're moving, whereas velocity is a vector because it does. If I multiply a vector by some number, we'll call that the scalar, and we'll call it number n, then all of my terms will be multiplied by that. So my a multiplied by some value n, or n times a, my coordinates or my vector will now be 2ni plus 3nj minus 4nk. So everything is multiplied by that same number. And therefore, if vector b is, let's say, 3 times vector a, in this example, that would mean that vector b represents 6i plus 9j minus 12k. In this way, we can start seeing when vectors are parallel. If you can multiply any vector times some number and get a different vector, then vector A and vector B must be parallel. If this number here is positive, then the vectors will be parallel going in the same direction. They may just be a different length if n isn't 1. If n is negative, then the vectors are parallel, but they will run in the opposite direction. So in summary, vectors have a size or a magnitude and a direction. There are several ways we can write vectors, and we're often going to see them written like this, or from one point to another. Vectors are unlike scalars because they have the direction. So a scalar, which could be speed, in a vector, that is velocity. We can add vectors by drawing them top to tail, like this, to get our resulting vector, a plus b. Or we can add them by adding our coordinates. There's one vector plus another vector, and our resulting vector would be something like this. And remember, when we subtract, what we actually do is we add the negative of our vector. So we turn it round the opposite direction. And finally, if we multiply a vector by a whole number or by any integer number to get another vector, then that will be parallel. And if n is less than 0, if n is negative, they will be in the opposite directions. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.